that are not in groups 1, 2, and 3, their charge can vary. So because their charge can vary, I'm going to use a Roman numeral to tell me the charge of my metal. So we need to use a Roman numeral because our charges vary. Okay. And to do that, we use that Roman numeral in parentheses. So remember, my Roman numerals are 1, 2, 3, 4, 5, and so on. You need to at least know the first 5. So in this case, I have vanadium and I have chlorine. So I look, and I first need to take my charges and crisscross them back up. Well, there's no numbers written, so that means that my charges must have been 1 and 1. So I bring those up, and I check. What was chlorine's charge on the periodic table? Well, chlorine's charge on the periodic table is -1. So that means that vanadium's charge must have also been +1 because their charges cancel out. So that means that I must have had vanadium 1 chloride. So our nonmetal is still named the same way with the IDE ending on it. I still take my stem like before, and my metal is still the entire metal name. I just have added in my Roman numeral to tell me the charge. So going the other way, when I write my elements as ions from a name, I first need to look at my Roman numeral, because it gives the charge of the metal, and for my nonmetal, I look at the number of valence electrons that's needed to get to 8, and that's its charge. Then just like before, I crisscross my charges down, and I only write the numbers, no positive or negative. And then finally, I reduce my subscripts. So here I have iron 3, so that 3 applies to my iron, so I have Fe plus 3, and then oxide. So ox is my stem, and that comes from oxygen, so O. On the periodic table, I look, oxygen is in group 6, so that means that it needs 2 more electrons to get to 8, so it has a charge of -2. I take my charges, I crisscross down, and I get Fe2O3. They cannot be reduced, so that means I leave them just like that. The last type of ionic compound is with a metal and a polyatomic ion, or polyatomic ion and a nonmetal.